Okay, after having these for a very long time, I'm finally going to do a video on them. These are both Logicube forensic hard drive capture units, and the idea is that these things, you can install a hard drive into them and copy information from a suspect's hard drive, laptop, what have you, and it can do it in a way that is verifiable and traceable and all that kind of stuff. And it can also do it in a way that will absolutely not alter the data on the original. That is very important, because if you're copying data off a suspect's hard drive and you do something wrong and you format the suspect's hard drive, that's kind of a big deal. So I have two models here. This is the SF-5000u and the MD5. As you can see, they're both pretty similar. They just have different interfaces. This one has a little terrible touch keyboard on it, and the external ports and everything are all the same on these, so I'll just show you one. It has a small fan, DC input jack. I've just been using a 12-volt one. And on the back we've got a parallel ATA connector, a little micro Molex connector for a power cable, which I have right here. It looks like this. Just plug it in, and you get one for the inside of it too. And there's also a 25-pin connector, which I assume is for a parallel printer, because one of the things on these is that you can print out, you know, a chain of command, of custody, and that kind of stuff. So on the inside, on the back, we've also just got like a little serial number thing. This is the one on this one. Basically the same thing. And inside, they just pinch open. We have a large hard cell pad, a foam pad here, and an internal fan connector. The connector for the power and for IDE, so you can install a hard drive inside it. And you would connect your target out here. So I'm going to go ahead and plug one in. So I also got a bunch of accessories with it. I got some cables. These are just standard IDE cables. I have some software, which we're not going to be using today just because it's old, and you know, we're not too interested in the software. This does USB forensic capturing. Now see, I thought this was just software to dump everything off this, but it says to boot it off it. So I believe what this is for is to take a suspect's machine, boot off this, and it will just dump everything over USB, although I'm not 100% on that. This is just drivers for Windows 8 and Windows 8 2nd Edition. And this is the Clone Card Pro software, which is just a regular blank disk. This is the Clone Card Pro. It is a Pcmcia card, and the idea is, I believe, that you pop this into a computer and then it just dumps everything off the laptop via the IDE connection to your cloning device. So it may go both ways. You may be able to dump the forensic information onto the unit itself, to the laptop from the unit. So I'm not sure on that, but you know, it's just a Pcmcia card. We'll crack this guy open. And what else did we get? Oh yeah, I got some serial ATA adapters. These are just serial ATA to power adapters, and they are actually made by Logitech and made in the USA. Got a couple of those. I've got this Logicube USB 2.0 Write Protect, and I was wondering what this thing was for. You can see it's an LED for high speed protected and link. This is actually to dump the data off this thing onto a computer via USB, and the idea is that this device prevents any data from being written to the device so that you don't accidentally alter your captured data. So yeah, plugging this into a computer does nothing, at least without this thing plugged in. So yeah, it's just a small circuit board inside we'll get to. And I also got just a 3.5 inch to 2.5 inch adapter. It's a pretty standard part, although it's pretty nicely made. I mean, aside from the power cable, it's got, you know, a fuse and stuff like that, and you can stick it down. It's got a little sticky tape. Okay, so I'm going to install a hard drive on this one. In order to do that, we need the adapter, because I just have a laptop drive. This is labeled focus, duplicator side, and hard drive side. So let's hook this up to the hard drive side. And it goes this way. Plug that in. Plug in our hard drive. 2.5 inch parallel ATA drives. The connector carries power. So basically all this is doing is converting the connection from a 40 pin to a lower pin count. I think it's 20 pin. And incorporating power as well. So let's get that plugged into power. Plug this into data as well. Okay, so now we have our target. And we'll just sing this kind of there. Okay. Oh yeah, and I forgot to mention there's also a CF card reader on the bigger one, the MD5. So let's give this thing some power. I've got a 12-volt power cord here. Plug this baby in. Okay. So there's a bit of a screen flicker. That's just because it's probably a CFL backlight. And we can go... the user interface on this thing is appalling, by the way. Software version... Firmware, options installed, none. Okay, so I guess it doesn't have anything fancy. Okay, so let's do the clone. And you can hear the fan. I don't know if this one's any louder than the other one, but these fans are brutal. Yeah. Oh yeah. So it's obviously attempting to power on an external drive that's not connected, but you get the idea of what it looks like. It'll then do a transfer. You can abort this. Oh, maybe it's waiting for the drive to get detected. Let's just do a reboot since it'll also kill that stupid fan. And yeah, you can go to drives, and there's like some information you can get out of it too, I believe. Oh yeah, you can set the printer. So I believe that's for the serial print, parallel printer. And word list. Perhaps that's for passwords. Oh, compact flash card must be installed. Hang on. I have an official Canon 32 megabyte CF card. Let's go ahead and use this just in case it wants to write anything to it. Let's see what it does. Okay, blah, blah, blah. Try that again, see what it says. Oh, okay, it's actually looking for a list. Okay, fair enough. And enable options, GPS. Oh, supports a GPS. Oh, that might be another thing that you can connect to that port. Enable option. Oh, this is for a paid upgrade. A lot of devices like this have codes that you can enter, a paid upgrade to unlock features, similar to how oscilloscopes work now. But yeah, that's pretty much all the software I want to deal with on these things. I mean, like I said, they're not very, it's really just a standard kind of copying interface. And the whole thing about these, like why they cost so much money, I believe this one has a price of like $2,500, and this one is presumably higher. Is that they're all verified and tested to perform in a way that you can take them to court, basically. So we'll open up the other one first, just to see if it has anything of interest. I've opened this one up before partially. You can see that there's a little warranty void sticker here, and it's just this this one piece that you can take off, and then there's a circuit board. Okay, so you just pull this guy off, and there's an opening here, which is what the warranty void sticker's for. And that actually works its way through to a flat flex cable, presumably for programming, or perhaps it's for an option of some type. There's also a flat flex here, which probably runs to the keypad. See if we can just take this guy off. Come on. Oh, well, hang on, let's see if we can get the board out. A couple screws here. Yeah, just 2 screws. One thing I notice about this one, we'll see if this is in the other one too, is that there are these little spacers here on the screws, and 3 of the 4 are rubber, and this one is just a couple like plastic ones that they stacked up. 3 of them actually, almost like they ran out of the other ones and they had to use those. So that seems a little odd, and it doesn't appear to have any more screws. Maybe we can just it's being held in by something. Unless there's some screws behind the sticker. Let me see if I can just get this flat flex off. Maybe this is partially to blame. Oh, yep, yep. Okay. Alright. Okay, so we have a display here, and we'll take these 3 screws off. These are just holding little washers to hold the display in. This is an older bitmap display. It's pretty large, and there's an awful lot of jumper links that they have on it. They've made some solder connections. Power tip. There's a chip on flex. Oh, it is actually an LED display, at least on this one. Perhaps the display is damaged on these, because I believe they both flicker. So it may be either damage to the display or they're just refreshing it very slowly. There's also a little resistor here, probably for the contrast adjust. And that looks like all there is to the case. I mean, we've just got this teeny tiny fan in the corner. These are actually super glued in. Yeah, so let me get this out of the way. Before we get into the boards themselves, I'm going to pull out this board too. This is from the more advanced unit with the keypad, which is presumably what this flat flex is doing. There's only 1 grommet spacer on this instead of 3, so either they determine they don't need more or they're missing for some reason. And we'll just go ahead and disconnect this. It's just a standard flat flex, as is this one. And this one has 2 screws as well. Exact same display unit, it just has the extra cutout for the membrane keyboard. Pretty much exactly the same. The boards, however, are very different. With both boards in hand, you can see there are quite a few differences. The power supply area is more or less the same. You've got the same input capacitors and whatnot, filtering and a switch mode controller. But once we move over, you can see that instead of the Atmel ATK40, which is an FPGA made by Atmel, we have an Altera Cyclone FPGA. Both of them share the same Infineon microcontroller, 16-bit, 20 megahertz basic microcontroller. That'll be handling all of the basic stuff, and this is going to be handling the actual data, the FPGAs. This one has the remove from the beeper sticker still on, and the beeper itself is, well, actually not. The reason why they probably didn't remove it is because the beeper is not actually attached to the board. It looks like it's just bodged on. It's connected to this little magnetic transformer, which is missing from this one for some reason. And yeah, we got 2 relays. Each one has 2 relays, presumably 1 to turn on each hard drive. This one has a little bodge wire running along from what looks to be a JTAG interface. This one has all the JTAG interfaces up the top and 1 down here. So does this. They're in pretty much the same place. They even both have an LED over here. And yeah, we've got kind of your standard flash memory. You got some working memory and probably a bit more flash. Some to control for the firmware and some for storage of records probably. This one has some additional components for the CF card reader. But other than that, I mean, this one just is more densely packed because it has more features. So also on the back you can see that there's almost nothing on the back of this except for connectors. This one has at least some passives, quite a few passives, but just passives nonetheless. And yeah, other than that, they're pretty much identical. They both say 2003, although this one says it's the MD5, and this one says it's from the Solitaire Turbo, which is another one of their products. I believe these may actually be called Solitaire, but I'm not sure. Let me, I'm just going to rip this thing off. We can see where this thing's connected. Oh no, it's actually got a solder hole for it. It's been soldered in, and there's another pin, presumably ground, or, well, yeah, maybe it's just drawing power from here. But either way, they obviously determined that that's not a good source. Maybe it's getting some buzzing or something, so they just rerouted it. Pretty simple fix. And we've got the very tall buttons and LEDs. Yeah, that's about it. I mean, they're fairly simple devices. I mean, they're using FPGAs to do all the grunt work. So let's take a look at some of the other parts. We've got one of these serial ATA adapters. This should probably just be a serial ATA to parallel ATA controller chip, probably made by Micron. Let's see. Oh no, sorry, I'm thinking Marvel or Marvell. Okay, so let's get this apart. We've got, oh yeah, there you go, Marvell controller. That is an 88i8030, which almost certainly is just a serial ATA to parallel ATA adapter. Got a little bit of support stuff, probably, I don't think it's going to be a microcontroller. It's probably just something to split some inputs from it or something. And a little clock crystal. And it's actually labeled Logicube serial ATA adapter. Made with pride in the USA. Anyway, what else we got? All right, let's take a look at this guy. This is the device used to dump the contents that you've copied off to your computer workstation for archiving or examination, what have you. Oh, little spacers that all fell out immediately. And yeah, this is just a Cypress. This looks like it just is Cypress USB microcontroller and a small Lattice CPLD. Now, I've noticed a lot of these Write Protect devices for forensic use have usually Lattice CPLDs on them. And from what I can tell, in my experience, I have a couple other devices made by other companies, is that what the Lattice CPLD is doing is it's basically faking information to the operating system. Because when you hook a drive up to this thing, or at least the other ones that I've tried, it actually shows up as a writable drive, presumably to avoid like weird complications with drives that it's expecting to be writable. And if you copy a file to it, it will actually copy. It will sit there and it will transfer the file, and it sits there like it's copying a real file. Windows will show the progress bar and it will finish, and the file will be there, but it won't be. Because the CPLD and presumably the microcontroller in some way are faking all of that and just sending back the confirmation of the written file. The actual drive itself has been completely protected by the CPLD and the whole unit. And it's really interesting because it actually does show that the file has been copied and it will show it there. I don't think you can actually read the files back. There's probably some limitation. Obviously, this thing would be able to store like gigabytes of data that you've copied. But the file directory information, I believe, is what it really handles. And yeah, we just got some LEDs and presumably some power stuff, because these things will use some weird voltages, and it even comes with a little programming header already attached. And on the back, there's just a little bodge wire. Made in the USA as well. 2003, just like most of the other stuff. Now, where is the clone card? Here we go. Now, this I'm going to need some brute force to get into. So this is just a standard Pcmcia card, high-speed cloning adapter. It is not a card bus slot, card bus slots have a gold contact, like a little colder compact, sorry, a copper contact here. So that's usually how you can tell them apart. This is going to be actually not that high speed. Very thick PCB. And presumably there's not going to be much on this thing, because why else would the PCB be so thick? But let's see if we can crack this baby open. There's no gentle way into these. I mean, you could sit there and try and bend the metal and bend it back, but yeah, it's a little excessive for something that's ultimately useless. And there's actually quite a bit in here from what I've already seen. Oh, there's 2 PCBs. Well, that explains why it's very thick on that end, yet still has a lot of electronics in here. Let's see if this wants to just snap off. There we go. Alright, basic metal shell of all Pcmcia cards. And internally we have, again, a very large lattice. This is probably an FPGA. And yeah, the secondary board, look how thin that PCB is compared to the PCB on the connector end, which they're obviously using for, let me see if this will focus properly. Never wants to when I need it to. And yeah, they've obviously used a very thick PCB just to give this thing some rigidity, because man, this is a very thin PCB. Look at that. Look, the connector, everything just bends super easily. The back has nothing on it. Pretty clean board. And yeah, it looks like they're just soldering a standard angled connector. So this is probably also providing some spacing for the pins. And yeah, just some memory. This is probably SRAM, and these are probably like level shifters or something, and just some odds and ends to give it power. And there's a little programming header, so it's a pretty beefy FPGA on that thing. Let me look that up. Turns out this isn't actually an FPGA. It's a Lattice ISP LSI 2128, which is an in-system programmable high-density PLD, which appears to be basically a one-time programmable FPGA. It's pretty beefy. I mean, it's got 128 I/O pins. It's up to 100 megahertz, and yeah, it's pretty powerful. So they must be doing a lot with it. It's just you know, a little unusual to see. I haven't really seen many of those. They're usually FPGAs, or in the case of the Write Protect USB stuff, they're almost always a CPLD or a very small FPGA.